Part 2, this is for questions 15 to 29. Question 15, factorize part a x squared minus 7x plus 12. Now this one is a quadratic equation which has 3 terms. So we need to convert this one to 4 terms and then we can split it into 2, then we factorize. So we look for 2 numbers. When we multiply them, we get 12. Okay? Actually, we say that the sum, okay, the sum is equal to this middle number, negative 7, and then the product is SC, okay, that coefficient of x squared, and then this constant term multiplied. So that will be a 12. 1 times 12, that's a 12. So we get 2 numbers. When we multiply them, they give us positive 12. But when we add them, we get negative 7. So since this one is a positive, the 2 numbers can either be both positive or both negative. So we can have 3 and 4. When we add these 2, we get a positive 7. But if I make all of them negative and I add them, then I will get the one? The negative 7. That means I will come here and I say the x squared minus 7x then plus 12 shall be equal to, is the same as x squared minus, actually let me take this one up here. I mean, I extend it this side, then I can bring this one here like this, x squared, then minus, in the place of 7, I put these 2 numbers, so minus 3x minus 4x, then bring the 12, so plus 12. Now you are seeing that we are having 4 terms, so we divide this one into 2, okay? Now what is common here? It is an x, so I pull it out, then that means I have x here, then minus 3. Then without wasting time, what I've gotten here as the first bracket is what I just put here, okay? I must get that bracket there. Then you ask yourself, what should I multiply with this x here to get minus 4x? That is minus 4, not so. Then I put the minus 4 here. So you can see that minus 4 times minus 3, you get this positive 12. You see that? Then we continue. You can see that this one is common. Okay? So that means if I pull it out, I will get x minus 3 and then x minus what? X minus 4. So this becomes our answer. So I'll just copy this and then put it there. Then part B, we have this one here. So you can see that in these 2, we are having 5 is common. So you have x plus 10, no, x plus 2y. Then how about here? We have 3n. So plus 3n is common. Then we are left with a 2, then y. So we have 2y and then an x here. So do you see that this x plus 2y is the same as 2y plus x? So that one is common. If I pull it out, the x plus 2y, then that means here I'll remain with a 5. Then here there is a plus 3n. So the answer will then be x plus 2y, then times, I can write 3n, then plus 5. I write the 5 last. Or even if you write 5 then plus 3n, it is all the same. Then question 16 is coming from sequences. The table shows 3 sequences. Sequence A, we can see this one is a linear sequence because we are adding a 5 here. You add a 5 here. You add a 5 here. Then you are also adding a 5 here. So the nth term, let us look at sequencing A. So since this one is a linear sequence, because it has a common difference, we are adding this 5 every now and then. Then the nth term of any linear sequencing, actually in A level, when you continue with math, we call this one an arithmetic sequence. Okay, so this is nth term is equal to A, then plus n minus 1 d, where A is the first term. Okay, and then D is the common difference. Okay, the common difference. So our first term here is 8. Then you leave the n minus 1. Then the common difference is this 5. Okay, this one. So times the 5. Then now we open the bracket. So this will be 8. Then plus 5n minus 5. So this implies that we shall have 5n. Then 8 minus 5. That's a plus 3. So meaning the nth term for sequence A is 5n, then plus 3. Then we go to sequence B. For sequence B, you can see that here we are adding a 1 on each of these numbers. Are we there? We are adding a 1 on each of these numbers. We are adding a 1. So it is also a linear sequence in the numerators. Then also down here, we are adding a 1. We are adding a 1. So it's also a linear sequence in the denominators. Okay? So we are going to do those two linear sequences. So let us look at sequence B. Now let us look at the numerator. So the numerator, the nth term, just like here, the first term is the 3. So we have the 3, then plus n minus 1 times the common difference, which is a 1. So meaning you have 3 plus n minus 1, which is n plus 2. So then in the numerator, I have n plus 2. Then in the denominator, what do I have? Maybe put this one here like this. For the denominator, what do we have? The nth term is equal to, the first term is a 2. Then we have n minus 1. Then our d is also plus 1. So we have 2 plus n minus 1. Okay, n minus 1. Then you get n plus 1. So we have n plus 1, like that. Okay. Alternatively, you could use positions and you say this is position 1, position 2, position 3, position 4. And then we look at now the terms. The terms we have are 3 over 2, then 4 over 3, then 5 over 4, 6 over 5. So positions, we call them the n. Okay. Now look at from 1 to 3. They added a 2, not so? From 1 to 2, they did what? They added a 1. From 2 to 4, they added a 2. From 2 to 3, they added a 1. 3 to 5, you added 2. Then 3 to 4, they added a 1. Same thing here, add a 1. But then here, you are adding a 2. So that means n, you add a 2 to get a numerator. That is what you're having here. Then again, for the denominator, you have your n, then you add a 1. This is your n plus 1. So alternatively, you can do it like that. See that? Then that is that. We can now go on and then we look at sequence C. Now when you look at sequence C, from here to this, we are multiplying by a 2. Not so? Multiply by 2, multiply by 2, multiply by 2. So such sequences are called geometric. Okay, and to find the nth term of such sequences, the nth term is given by, the nth term is given by a r then to the power of n minus 1, and a is the first term, then r is called the common ratio, where you say this one divide by this. In other words, you look at what is being done here. You see that? So we can have the first term is a quarter, then r is 2, because they are multiplying all through by 2 power n minus what? 1. Okay, then we can write this one as 2 to the power of negative 2, then times 2 to the power of n minus 1. Now this is multiplication. What do we do to the powers when it comes to indices? We add them. So we have this one here minus 2, then plus n minus 1. And this one gives us 2 to the power of n, then minus what? 3. So the nth term is 2 to the power of n minus 3. Okay, so that is that. But there is an alternative approach. When you look at these terms here, they are powers of 2. So let me also put it here. Let me try to fix it here. Alternatively, you can have the positions are n. So we have 1, 2, 3. Let me just use the first 3 terms, okay? 1, 2, and then 3. Then we have the terms here. And in the terms, the first term is 1 over 2 squared. Are we there? Which is the same as 2 power negative 2. So I'll just say 2 power negative 2. Then this one is 2 power negative 1. Then the third one here, it is 1. That is 2 power 0. Now I want you to look at the powers here, and then you relate them with those numbers, the positions of the terms. So from 3 to this one here to 0, you are subtracting a 3. From 2 to negative 1, you are subtracting a 3. From 1 to negative 2, you are subtracting a 3. So that means the nth term is going to be this one here. The n, then subtract a 3 as the power of what? Of the 2. Does that make sense? Okay, so that is that. Question 17 is coming from trigonometry part. Sketch the graph of y is equal to cos of x for the x ranging from 0 to 360. Now, I will put a 90 here, 90 degrees, then here 270 degrees. Now, cosine of any angle does not go beyond 1, and neither is it less than negative 1. So, to avoid that mistake of going beyond 1 and negative 1, I would draw a line here. Okay, that line there. Then I'm going to make it dotted so that it doesn't interfere with the curve that I'm going to draw. Okay, then after that I'm going to duplicate it, then also put it here at negative 1, just like that, to guide me when I'm drawing. Cosine of 0 is a 1. Okay, cosine of 0 is a 1, so I'll plot here. Then cosine of 90 is a 0, so I'll plot here. Then cosine of 180 is a negative 1, so negative 1 is, then I go down to be there, so I'll plot here. And then cosine of 270 is a 0, so I'll plot here. Then cos of 360 is a 1, so I'll plot here. Now I join these points like that. I'll come down here, connect with this one, then here, and then I continue there like that. I have to curve it off, okay, like that, because it doesn't go beyond this one here. Don't draw like as if it is coming like that. No, curve it off. This is the maximum, this is its what? Minimum. Are we there? Yes, so that is y is equal to cosine of x. Then part B, cos of x is 1 over root of 2, and x is a reflex angle. So if it's a reflex angle, that means it is greater than 180, okay? And let's say less than 360 degrees. You see that? So that means when we draw our unit circle, I've always used this unit circle. So in the first quadrant, all are positive. In the second quadrant, it is only sine. In the third quadrant, it is only tan. And in the fourth quadrant, it is only cosine. So suppose I draw an angle there, and then also the same angle down here. So if here we have an x, then opposite angles are equal. Even this one is x. Again, this is x. Then even this one will be x. Now, this is 0 degrees. When you go anti-clockwise, the angles are positive. When you go clockwise, the angles are negative. So this one will be 90 degrees. 90 degrees, then 180 degrees, 270 degrees. By the time you come back here, this is 360 degrees. Are we there? Then next, of course, to move from here up to here in the third quadrant, that is 180 here, then plus the x. So we have 180 plus the x. Then to move from here up to here, you'll get the whole total, which is 360, then minus this x here. Also, so 360 degrees minus the x. And then, of course, this one will be 180, then minus the x. That is if you are getting an angle in the second quadrant. Now, here we are looking at these two quadrants, here and then here, okay? But then when you look at the sign of this one here, it is positive. So cosine is positive in the first quadrant and fourth quadrant. Are we there? Even when you look at this graph here, okay? In the third quadrant, in the first quadrant, cosine is positive. In the second quadrant, it is only sine which is positive, right? So you find that this curve between 90 and 180 is below the x-axis. You see, it is a negative. In the third quadrant, it is also below the x-axis. It is a negative. But then above 270 to 360, it is above the x-axis. So it is positive. You see? So our answer is supposed to be got from the first quadrant and then the fourth quadrant where cosine is what? Positive. But since they said x is reflex, then that means we are not getting an angle in the first quadrant. Okay? 1 over root 2 might be around there. So if I draw this line, maybe that is the 1 over root 2. You can see that it intersects this curve in the first quadrant because cosine is what? Positive. Then it also intersects this curve in the fourth quadrant. Again, that is where cosine is what? Positive. Do you see that? So now you will go to you will go through my channel and you look at the specimen papers that I did. I'm actually going to attach the link, okay, in the description, and then you see how we get the exact values of cosine, sine, tan of angles of like 30 degrees, 45, 60 degrees, okay? But then here, so our x is going to be the arc cos of 1 over root of 2, which is a 45, okay? Which is a 45 degrees. Now, 45 here, since this one is positive, we also go to the quadrant where cosine is positive. So this one is in the first quadrant, the 45. So to get an angle in the fourth quadrant, it is 360, then minus the 45. So that means this one will give us 315. And that one is going to be our answer. So we are not going to take this answer here because it is not a reflex angle. This is the reflex angle. Is that clear? All right. Question 18. Shade the region in each Venn diagram. We have A intersection B complement. So A intersection B is actually this one here, okay, in the middle. But then when they say complement, that means outside of this. So that means we are going to shade everything outside of this region. So we only leave this region here, okay? So like that. Then part B, C union D, intersection E complement. So what we are going to do, we are going to get C union D, okay? That is everything in C and D. So you get, let me change the width of this. I get everything that is in C and D, those two sets, okay? Then after that, intersection, that means pick a common region. Then what is outside of E? So what is outside of E is everything like this, okay? Outside of E. Now what is the common region? It is, okay, this one here, here, and here. You see, outside of E, but also in C union D. So these are the points we are going to shade. So those are the regions. So that's what we are supposed to shade, okay? All right, so let's do that like that. Question 19. The diagram shows a circle center or radius 12 centimeters. Part A, work out the area of the minor sector A or B. Give your answer in terms of pi in its simplest form. So area of a sector is just a portion of a circle, okay? You can see it is just this minor portion. But this arc here subtends an angle of 60 degrees. So we shall get 60 out of the total sum of angles in the circle is 360. So that is its portion. Then times the area of the circle, so which is pi r squared, and the radius is what? Is 12. Now, this one can go in here. 6 can go into 36 6 times. Are we there? Then 6 can go into the 12 2 times. So that means we are getting 2 pi. That is our answer here. Remember that you said you leave pi in your answer. Okay, then next part B. Calculate the length of the major arc. So length of an arc is equal to theta out of 360 degrees, also times, but now an arc is part of the circumference of a circle, okay? So we shall multiply by the circumference of a circle, which is given by 2 pi r. You see that? Now, length of major arc, this one changes a little bit. Length of major arc. Now this one can be for the minor arc. So the angle it subtends at the center of the circle is this one. So look at how the arc looks like. It is like this. That means the angle it subtends at the center also looks like it. So it has to be like that. Look at this arc here. Then the angle it subtends at the center. Look at this arc also, how it looks like. This one, which represents an angle. You see that? It resembles this one. So here we shall have 360, then minus the 60. Okay? Because you know that angles at a point sum up to 360. Okay, then divide by the 360 degrees, then times 2 pi, and then our r is 12. So here we have 300, not so? Then divide by the 360 times 2 pi, and then r. Okay, now, how do we simplify this? Take away the 0 and that, okay? Then we have 12 here, goes into 36 3 times. Are we there? Then 3 goes into 30 10 times. Now 10 times 2, you get 20. So we shall get 20 pi as our final answer. Oh, pardon me, up here I think I messed this up. The area of a circle is pi r squared, okay? So I have to put a square here. So meaning, if this one is 1 over 6, we have 1 over 6, then times, let me actually write it, 1 out of 6, then times pi, times 12, times 12. Then this one can go here 2 times. Now 2 times the 12, we get 24. So our answer here is 24 pi, not 2 pi. Pardon me here. 24 pi. Question 20, work out 0.11 and then a 4, then plus the 0.2. Now, if I can zoom this one, you can see that the dots are put on this one here and the 4. So that means these are the ones that are recurring. So I need to convert this one to a fraction, okay? And also this one to a fraction, then I solve them, okay? All right. Now, the first thing to do is to make sure that we have the recurring part on the right side of the decimal point. So if we have x, which is equal to 0.1, then 1 with a dot, and then 4 with a dot, we first multiply all through. In fact, I can write 1, 4, 1, 4. Okay, it goes on like that. Maybe that is my equation 1. Then I first multiply all through by 10 to remove this one here that is not recurring. You get it? I need only the recurring numbers on the right side. So multiply all through by 10. That means the decimal here will jump and then goes there. So we shall have 1, then point. Now 1, 4, 1, 4. It goes on like that. Okay, this is my equation 2. Then now we look at the numbers which are recurring. There are 2. That means we multiply all through by 100. So when you get this one and you multiply by 100, you get 1,000. Also, then here you will get, now this one will jump and then comes there. So it will be 1, 1, 4, then 0.14, then 1, 4. Because this one is recurring, so I will maintain the decimal places. Therefore here, then even here, such that when I subtract, the decimal places will go. I mean the recurring part will go. Okay, so I will now get this equation 3. Then I subtract equation 2. Okay. Okay, so we have 1,000 of x. Then this one is equal to 114.1414 recurring. Then we have 10x here, which is equal to 1, then 0.1414. So when we subtract 1,000 minus 10, that one will give us 990, not so, of x. Then this one will be 114 minus 1, that will be 113, not so. Then this one will go. So that means our x here is going to be 113, then divide by 990. Okay, can we simplify this and maybe we divide all through by 3? Let's see. We have a 99. 3 can go into the 99. So the next one will be 102, then 105, multiples of 3, okay? 108. Then we have 111, not so? Then the next one will be 114, and this is 113. So I can't divide through by 3. So I'm just going to use that one there. They actually never told us to even maybe give the answer in the simplest form, but just a fraction. Now, after finding a fraction here, the next thing to do is to add it to this one here. So we shall have 113 out of 990, then plus the 0.2. The 0.2 is the same as 2 out of 10, not so? 990, so it is 2 out of 10. Then our LCM is going to be 990 because 10 goes into this, not so? So 990 divided by 990, you get a 1, then times 113. So we shall get 113 here. The 990 divide by 10, you'll get 99. 99 times 2. 99 times 2. You'll get 18 here. Take 1 here. Again, 18 plus 1, that is a 9. So, that's a 19. So we have 198. Now those two, we can add them. 113 plus 198. What do we have? We have 11 here. Then take 1, that is 10. Then 11. Then take 1 here. We get 3. So our answer becomes 311, then out of 990. Then question 21 is coming from circle theorems. The diagram shows a cyclic quadrilateral. That means sum of opposite angles will always be equal to 180 degrees. Opposite angles in a cyclic quadrilateral add up to 180 degrees. Now let us add these two. We shall have y plus m plus 10. Then this one will give us 180. Okay. I'm going to avoid writing degrees. Let me just write equations like that. Okay. Then we also have p plus m, which is equal to 180. Because when you add these ones, okay, you get 180. They are opposite. But now they give us the ratio. That is the same as fractions. So let me actually put this one this side. Then begin with this one here. We have p out of m. Let me put one also down. We begin with p to m is equal to 2 to 3. So this means p out of m shall be equal to 2 out of 3. So I can express one in terms of the other. Maybe p in terms of m or m in terms of p. Okay. So when we cross multiply, p will be equal to 2 out of 3 of m. Okay. Now I can substitute here. So p is 2 out of 3 of m, then plus m. This one will give us 180. Okay. Now 3 times this, you will get 3, then plus the 2, that will give us a 5. So we get 5m, then out of 3, which will be equal to 180. Then our m will be cross multiply. You have 180, then times 3. Then after, you divide by what? 5. Okay. 5 goes into 18. How many times? 3 times. Not so? So that will be a 15. 3 times 5, that's a 15. Then 18 minus 15, you get a 3. Then when I put a 3 on this 0, it becomes 30. Then 30 divided by 5, you get a 6. So meaning we shall have this one going here 36 times, then now times this 3. Okay, 36 times 3, that one gives us 108. So m is equal to 108 degrees. Okay. Or I don't even need to put degrees because the degree is already there. So these are just constants. You see, p here. You don't need to put degrees because it was already put there. Okay, so we have this one here. Now we can come to this. When we come to this one here, y, then plus. In fact, I'm going to say y is equal to 180, then minus these 2 here, where m is 108, and then also the 10. 108, then plus 10, that is 118 also. So that means we shall have 180, then minus 118. Now I need 62 to add it on 18 to get what? 80. So this will be a 62. So that means our answer is 62. As simple as that. Question 22. The equation of the line L is this one here. Find the equation of the line perpendicular to L that passes through this point. Give your answer in the form y is equal to mx plus c. Now, you should know that a line that is perpendicular to the other, the product of the two gradients of the lines is always equal to -1. And if we are to find a gradient, I mean the equation of a straight line, we need at least one point through which a line passes and its gradient. So gradient of the perpendicular line, okay, it has to be gradient of perpendicular line, perpendicular, then line shall be equal to -1, okay? Divide by the gradient of this one is -1/2. It's -1/2. So that means here we shall get a 2 because this one will somersault and then comes there. But then a negative divided by a negative is a positive. Are we there? Then the equation of this line is going to be y, which is equal to the m, we have gotten it as a 2, then x, then plus c. Now our mandate is to find the value of what? Of c. Now we need to use this point here. If a point lies on the line, that means its coordinates must satisfy the equation of that line. So I have 3, then 5. So our y is a 5, and then our x is a 3. So plus c. This will be 5, then take this one this side, which will be a -6, and then your c becomes a -1. So meaning the equation of the curve, the equation of the line is going to be y is equal to 2x, then -1. Then question 23, work out the area of a triangle. Now, a triangle which is not right angled, to get the area, it is 1/2 AB sine c. In other words, you get 1/2 times this side, times this side, and then they included what? Angle. You see that? So area of the triangle, then is equal to 1/2 times, then we have the 6 times the 10, and then sine of 30. Again, when you check in the description, you will see how we get sine of 30. It is actually question number 21 in that. It is a specimen paper, I think, yes. So you see how I did these ones using the equilateral triangle, and then for 45, I used the isosceles right angled triangle. So what do we have here? 1/2 of 60 will be 30. Then sine of 30 is 1/2. So 30 times 1/2, that one gives us a 15. Question 24, I'm seeing it is coming from Surds. Simplify this one here. So numbers of the sort, what you have to do is to split these numbers into 2, okay? And then one of the numbers has to be a perfect square. So this one here is 5 times 5 times 5, which is the same as 25 times 5. So we have 25, then times 5. So I've expressed this one in these two numbers as a product of the two numbers, but one of them is a perfect square, which is the 25. The same thing to this one here. A perfect square here is going to be 4. Then again times what? 5. Then, and when they say simplify, that means that other number has to be the same such that you can simplify. So here we shall have root of 25, then times root of 5, then we can subtract root of 4, then times root of 5. Root of 25 is a 5, okay? And then root of 4 is a 2. Then surds are said to be added or subtracted if the number under the square root sign is the same. So there is this and this one here, which is the same. That means we can simplify these ones here. So 5 minus 2, we get a 3. So we shall get 3, then root of 5. Then part B, we are given the rectangle here, and they are saying that its area is k centimeters squared. Work out the value of k. So area of a rectangle, it is equal to length times width. So it will be 3 root of 8, then times 2 root of 2. Okay. Now we are going to have 3 here times 2. That one will be a 6. In fact, let me do it like this. That is 3, then times the 2, then times root of 8 here, times root of 2. I'll just put these ones inside here because we have a rule in indices. In surds, okay, that root of A times root of B is the same as A, B, then under the square root, okay? So that is what I'm having here. And this one will be 6, then times root of 16. And you know that root of 16 is a 4. So 6 times 4, then this one gives us a 24. But see, rationalize the denominator. So we get the conjugate of the denominator, we multiply it by the denominator and then the numerator. So we are going to have 1, then out of, I'm going to do this one using two methods. So 1 here, then out of, we have root of 7, then plus 2. The conjugate can be when you change the sign of this one, okay? We have this, then minus 2. Now what you have done down here, you also do it up here, okay? But usually when we are finding the conjugate of the denominator, which happens to be a surd, we change the sign of that surd part, okay? We change the sign of the square root of 7, okay? So that is the other one I'm going to do. Now let us open the brackets. So this will be root of 7, then minus 2, and then down here, this will be a difference of 2 squares, okay? So you just say root of 7, you square it, then minus, then you put 2, and then squared, because a squared minus b squared is equal to a plus b, then a minus b. This is what we call difference of 2 squares. So now here, we shall have root of 7, then minus 2, out of, when you square this one, it will give you a 7, then here you have a 4. So meaning your answer is going to be root of 7 minus 2 out of 3. So you can write root of 7 minus 2 out of 3. Or you can split it into 2. You say root of 7 over 3, then minus 2 out of 3, okay? Now, alternatively, suppose another person did this. Alternatively, this one is also marked right. I can have 1 out of root of 7 plus 2. Then we say that this is the same as 1, then out of, you change the sign of the surd. So it will be, this is root of 7 plus 2, then you multiply by negative root of 7, okay, plus 2. So that will be the conjugate of the denominator. You just change the sign of the what? The surd part. So you also do the same up here, because it's like you have done nothing. So minus root of 7, then plus 2. Okay, we continue the same process. So we have negative root of 7 plus 2. Down here, you have root of 7 times root of 7. What do you get? Root of 7 times root of 7, you are getting a 7, not so? But there is a minus, so we have a minus here. Then root of 7 times 2, you are getting 2 root of 7. Then 2 times minus root of 7, that's a minus 2 root of 7. And then a 2 times a 2, that's a 4. So you see this one goes. And then we are having minus 7 plus 4. What do we get? Isn't that a minus 3? So plus 2, then out of a minus 3. So you can see that you're having minus root of 7 out of minus 3, and then plus 2 out of minus 3. Then this one can give you, this one becomes a positive, okay? Just like here, root of 7 over 3. So we shall have root of 7 over 3, and then this one is minus 2 over 3. So you can see, you either write this or this one. So both give you the same answer. Question 25. Mahil picks one number at random from the numbers 5, 10, 15. He then picks one number at random from the numbers 4, 5, and 6. He adds the two numbers. The sample space diagram shows some of the possible outcomes. So this is the one here. Then they are telling us to complete the sample space diagram. So you just get this plus this. What do you get? A 9. Because 10 plus 4 is a 14. 15 plus 4 is a 19. You see that? So we just add. Now 5 plus 5, you get 10. 5 plus 6, you get 11. As simple as that. Then next, given that the total of the two numbers is odd, find a probability that one of the numbers added is a 15. The total is odd. Okay? So where do we see odd? Or the total? We have a 19, we have a 21, we have a 15, we have a 9, we have an 11. Are we there? Then 15, yes, I find the probability that one of the numbers added is a 15. So we are seeing 15 come to this one here, the column of 15. And this is, we are getting only 19. And then what? The 21. You see that? So that means these are 2 out of the whole total. How many are they? 1, 2, 3, 4, and 5. So that will be 2 out of what? 5. So I'll write 19 and 21. So those are 2. So I'll write 2. Then out of, there are 5 of them. Okay. Okay, let's say sum, because I want to be systematic. Sum of two numbers is odd. So that sample space has gotten 9, there is 11, there is 19, there is 15, then 19, and then 21. Okay, then numbers. Okay, numbers added. I can say 15 is one of the numbers. You don't need to write all of this in the exam. I'm just putting this to explain this very well. So 15 is one of the numbers added. Okay, so we are seeing 19 and 21. We have 19 and then 21. Now the probability is going to be these two divided by the total, which is 5. And then question 26, write as a single fraction in its simplest form. Of course, we are going to simplify here. M will go with that, okay? And then here we are going to divide. In fact, let me do the simplification here. MP, then out of the 25 of y. In fact, let me write 25 as 5 times 5 of y, then is equal to, this one is 5, no, it's not equal to, just multiplication. So times, this one is going to be 3, then times 5, then out of the m. So this one will cancel with this, a 5 will cancel with the 5. That means up here we are remaining with 3 times p, which is 3p. Then out of, this is 5y. Okay, out of 5y. Then part B, we are supposed to write this one also as a single fraction. So to get the common denominator, because you cannot solve fractions when you don't have the common denominator. So what we do, we call this one the butterfly method. So you multiply these two denominators, then you multiply this with this, and then that with that. So you are going to have 3 multiplying with x minus 3. Then you have the 4 here multiplying with 2x minus 5. So if here we have a minus, please put a minus here. Simple as that. Then down here, we shall have 2x minus 5. And then here you have x minus 3. Now, the next thing to do is to simplify the numerator. Don't waste time multiplying all through the denominator. No, just simplify the numerator. So when you open the brackets, we shall have 3x, then minus 9, then plus 8x, then minus 20. Then we divide by this 2x minus 5 and also x minus 3. So our final answer is going to be 3x plus 8x. Isn't that 11? that is 11x, then minus 9 minus 20, that is minus 29. Then out of this is 2x, then minus 5, and then this one will be x minus 3. And that is that. Question 27, solve the simultaneous equations. This one is nonlinear, this one is linear. So we can substitute. Here we are supposed to solve them using substitution method. So if y is the whole of this, and then here they say y plus 2 is equal to this. So where there is y, I'm going to put this one here, okay? So we shall have x squared minus 8x, then plus 22. Now there is plus 2 here. Then this one is equal to 3x. Now we'll bring everything onto one side such that we form one quadratic equation which we can solve. So we have minus 8x, then minus the 3x. Then this one is 24. Then this one will be equal to 0. Now simplified, it will be x squared minus 11x, and then plus the 24, which is equal to 0. So I can use factorization. We get two numbers. When we multiply them, we get 24. I can have 8 and 3. But when we add them, we get negative 11. So both of these numbers can be negatives. You see that? Minus 8 minus 3 will give us a minus 11. But minus 8 times minus 3, you'll get a positive 24. Also, so we shall get x squared. Then where this negative 11 is, I replace it with the minus 8 and the minus 3. So we shall have minus 8x minus 3x, then plus the 24. This one will be equal to 0. Then these ones were, first of all, these ones were 3 terms. Now they are 4 terms. So you split this into 2. So what is common here? Then what is common here? Okay. Now what is common here is an x. So I'll write x. Then we have x here minus 8. Then don't waste time when you come to this. Just get this bracket you have gotten and then duplicate it here. So you put here x minus what? 8. Now ask yourself, what should I multiply with this x here to get a minus 3x? Automatically it is a minus what? 3. Now do you see that minus 3 times minus 8 then gives you the 24? Okay, so this one is equal to 0. Now what is common here is the x minus 8. Okay, and then x minus 3, which is equal to 0. Now, this can only be equal to 0 if, let's say, this whole thing here is 0. So 0 times x minus 3, then you will get the 0. Or we can get this one, and it is a 0, then times this x minus 8, you will still get a 0. So that's why we get those factors, and each of them we equate it to 0, okay? So x minus 8 is equal to 0. That means our x here is going to be equal to 8. The same thing here, x minus 3 will be equal to 0. And then x becomes a 3. As simple as that. Then for each of these values, we are supposed to get the values of y. So I can substitute here, or I can substitute in here. Okay. So y then plus 2 is equal to 3. Then x. So meaning y will be equal to 24 here, then minus 2, which gives us a what? A 22. Now to avoid doing mistakes, when x is 8, y is 22. So you put it here, 8 and then 22. Okay? Don't do 8, then the 22 here, please. You can actually lose a mark. You have done the whole of this, and then when you are writing your answers here, you write them wrongly. The other x value is 3. Then what is the y value? So we have y again plus 2, which is equal to 3, then times 3. So meaning y will be equal to 3 times 3 is a 9, then minus 2. This one gives us a what? A 7. So that means I'll write my 7 there. Then question 28, simplify this one here. So that means we are supposed to factorize this one here, and then we also factorize down here, okay? Now, we are going to get two numbers. When we add them, we get negative 11, but when we multiply them, we get this 2 times the negative 21. Okay, so we have the sum. Let me write here, sum is negative 11, then the product is 2 times negative 21, which is actually negative 42. Now, how do we get 42? 42 can be 2 times 21. That one cannot give us this. Then we also have 3 times what? 3 times 14. Yes, we can have 3 and 14. They can give us an 11. So since this one is a negative, that means one of the numbers is a negative. So we can have a negative here, and then we leave this one positive. Or we can have this 14 when it is a negative. You see that? But then which of these two, this one here or this one, adds up to this? So when we get negative 3, then plus 14, it will give us a positive 11. Then when we get 3 plus the negative 14, this one will give us what? A negative 11. So those are the two we are going to take, okay? So that means here we shall have 2x squared, then minus 14x. So these two numbers, I put them in the place of what? Of x. So we shall have 14x here, then minus, I think there is a plus 3, okay, because this one is positive. So plus 3x, then minus the 21. Then we divide by, this is a difference of two squares. So you write x squared, then minus 7 squared. Then here we shall have what is common here, which is 2x. So I pull it out, 2x. That means here I will remain with an x. And then here I will remain with a 7. So minus 7 here. Then plus, you don't waste time. You just put that x minus what? 7. In other words, when I pull out a 3, okay, I get this one here. So 3 times the negative 7, then you get the negative 21. And then down here, this one is going to be x plus 7, and then x minus 7, difference of two squares. Now here what is common is x minus what? 7. So I will have x minus 7, it is common. Then here I'm left with 2x. And then here I'm left with a plus 3. Then here we shall have the x plus 7, then times the x minus 7. So this one here can cancel with this, okay? And then our answer becomes 2x plus 3. Then we divide by x plus 7. So when they tell you simplify, that means there is a factor that is going to cancel out in the numerator and the denominator. And for this case, we have seen it is x minus 7. You see that? Then lastly, question 29. In this question, all measurements are in centimeters. Solid A is made from a cylinder and a hemisphere, both of radius 2r. The cylinder has the height 5r. Solid B is a cone of radius r and sloping edge x. The total surface area of solid A is equal to the total surface area of solid B. Find r in terms of x, okay? So total surface area of solid A is equal to total surface area of solid B. Now, the total surface area, we are having this one here as the circular part, okay? So this is area of the circle. Then we have this curved surface here. Curved surface area of a cylinder is 2 pi r/h. How does it come to be so? If like you are having your paper, okay? You get any paper, it is rectangular, okay? Then you fold it, it will form this cylinder. Are we there? Now, if I cut, let's say I was having the cylinder already like this, then I can cut it into, I can cut it here, then it opens up. When it opens up, you will have something like this. Now, this part here, okay, this length here opens up and it gives you this one. So what used to be the circumference of this circle, and circumference is given by 2 pi r. It is the one that spreads and gives you this length here. So the height which is here remains. Are we there? The height remains. So for this case, maybe it is the 5r. So that's why the curved surface area of a cylinder is equal to the area of the rectangle, which is 2 pi r, that is its length, then the h. Okay? All right. Now, these ones are actually given in the list of formulae. Okay? So here we shall have the circular base. The circular, like I would say the circular base area. The circular base area. Then plus, we shall have the curved surface area of the cylinder. Curved surface area of the cylinder. Then we have this curved surface area. We are not going to consider this circle here because it is covered in, okay? And for curved surface area, we are looking at that area outside. You see that? Okay, so we shall also add the curved surface area, curved surface area of the hemisphere. Then we go to this side of the cone, there is this circular end. So we shall say the circular area of the cone, then plus the curved surface area of the cone. Curved. Let me try to save some space here. The curved surface area of the cone. Now, circular base area is of course pi r squared. So we shall have pi here. Then our r is 2r, 2 capital R, okay? Then squared. Then plus curved surface area of the cylinder. It is 2 pi RH. So it is 2 pi, but the r is 2r. Then the h is 5r, okay? 5r. Okay, let me take you to the list of formulae and then we see this. So when you come to page 2, you can see here curved surface area of the cone is pi rl. Okay, then curved surface area of the cylinder is 2 pi rh. Then surface area of the sphere is this one here, 4 pi r squared. That means the surface area of the hemisphere, okay, will be the curved surface area, then plus the area of the sphere. But since on the other diagram we are having our cylinder like this, then we have something like this. So we shall get a half of the surface area of the hemisphere. So a half of this will be 2 pi r squared. So curved surface area, we have seen it is 2 pi, then r, and then h. Then we go to the curved surface area of the hemisphere. It is a half, then times the curved surface area of the sphere, or the surface area of the sphere, which is pi r what? Squared. But the r is 2r here, then squared. Then we go to this side, circular, the circular base. I think there is an r here. This one here is pi r squared. So pi, we have pi, then r squared, and then plus the curved surface area of the cone. It is pi r l, pi, then r, but our l is this x here. So they said find r in terms of x. Now let us simplify. This one will be 4r squared. So 4 pi r squared. And then r times r, that is r squared. So here we have 2 times 5, that is a 10, times 2, that is 20. So 20 pi, then r squared. And then here, of course, when I square that, it will go to r squared. Then this 2 goes into the 4 2 times. So 2 then times the 4 that comes from here, that will be 8 also. So we shall have 8 pi then r squared. And then this other side, we have pi r squared then plus pi r then x. So they want r in terms of what? In terms of x. So I can actually simplify this one here. This is 24. 24 plus 8. What do you get? Isn't that 32? So we shall get 32 pi r squared. This one will be equal to pi r squared then plus pi r and x. Bring this one this side. So you will have 31. Okay, 31 pi then r squared. This one will be equal to pi r then of x. So what is common is pi and then r. So we shall get 31 here then times r, then will be equal to this pi r, which is also common. So I can have this one cancelled. Then we have 31 of r then is equal to the x. Not so? But we are finding r in terms of x, so that means r will be equal to x out of 31. So we write here x out of 31. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.